Okay, so I'm going to demonstrate my website. So for the first page, it's just a overview of the depression dataset that I choose from the Kaggle website. So from here, you can select any columns from the dataset and see the spread of the dataset in a box plot. So for example, if we select financial stress and we add the column, we can see the spread of this feature. And if we continue at like different thing, let's say age, this is like at this part because it just have too many different age, while the financial strat is just only value 1 to 5. You can see the most common age is 56 years old with 33% at that age, and most common in financial stress is level 2 with 400 people select this part. And if we keep selecting, let's say sleep duration and work hour, and just stuff like that, we get to have a sense of this how spread is this data set. Okay, so after this one, we can click on the bar plot. This is also just an overview of the data set. This part is the person without depression, and this part is the person with depression. So in this data set, there's actually just 200 people with depression, so it's not ideal. And I will process it using small library in the further model analysis. So for the analysis result, this is the PCA, and you can see a lot of blue data point and some red data point. Blue data point are the person without depression, while the red one are the person with depression. So if we zoom in a little bit and let's select one blue dot, and you can see the detailed information of this selecting data point. And if we click on say this part. Okay, if we click on this red data point, you can see this person does have a depression, and this person's detailed information is displayed right here using API. And okay, so next we can go to KM model. This is just a model. After you enter some certain information, you can predict your chance of getting depression. And let's say if I say I'm female and I'm like 34 years old, I have work pressure as 3. I'm satisfied with my job. I sleep 7 to 8 hours. I eat normally. I don't have thought of suicide. I work like 2 hours a day. I don't have much financial stress, and I don't have family history of mental illness. And I choose a number of neighbors. If I don't choose it, the default is going to be 2, but I'm just going to choose for 3 neighbors here. And after we click the prediction, you can say it predict, oh, I'm not depressed. And how accurate is this prediction based on the data set? The accuracy for the testing data set is about 90%, and for the training data set is about 96%. So this prediction result is good. And if we try to do another one, let's say the age is about 18, and it's very pressures and not satisfied with their job. They sleep very less. They have unhealthy dietary habit. They have suicide thought. They have 10 hours a week, 10 hours per day to work. They are very stressful about their financial. They have a history of mental illness, and we also choose the same. I don't remember how many neighbors I choose before, so I'm just going to choose for 5. And this is definitely going to have a lower accuracy, because in this data set, the higher number of neighbors you choose is actually causing the accuracy drop down, and you can see it's 88, while we have like a 90% accuracy before. You can see the prediction result is depression. You can observe that the background color is different. It was green before. You can see this accuracy is also dropped about 1%. So that's basically it for the KM model. And then for the logistic regression model, similar thing happened. The only difference is instead of choosing the number of neighbors, we can choose the size of training data set, because apparently logistic regression doesn't have a parameter called number of neighbors. So if we input the same information, I don't remember. Before, say I'm I'm very satisfied with the job. I sleep healthily. I eat normally. I don't have a suicide thought. I work like 6 hours per day. I have some financial stress, and then no mental illness. And I choose about, let's do like 0.8, like 80% of the data is used for training. This could make our prediction accuracy go a little bit higher. So you can see the result is also not depressed, and the accuracy is much higher, it's about 97%, and this one is also 97%. And if we change a little bit, let's say the exact same result, 78 hour, I think. And then some financial stress, no mental illness, and this time I only choose like 0.1, so only 10% of data is using to train the model. And you can see this accuracy dropped down from 97% to 94%. But the prediction result is still not depressed, as this accuracy is still high. And we can try another one, and let's say it's about 19 years old, very pressure about their job, not satisfied, sleep less, they eat very unhealthy, they have suicide thought, they work like 10 hours per day, very stressful, and let's say the training data is still 0.1. You can see it's as depressed, and this accuracy is 94%, and it seems, yeah, just good result. So that's basically it for my website. Thank you.